Okay, we'll solve. Few of you have answered this. Okay, so when we see this circuit, so let's try to make this circuit more simple. Okay, okay, students. So here we need to find out I1, I2. Okay, this is I2. Arrow is like this. Okay, so that means this is my I2 and this is my I3. So similarly, I have just used the symbol, resistance symbol here, and current values I am putting like this. So looking at this diagram, can you tell me what is my I1? This one. Very good. You can see that a 2 ampere is flowing like this. So this I1 is nothing but 2 amperes. Okay, so that means this I1, which is 2 amperes, is like this coming here. Okay, and this is a node where my current is getting divided into I2 and I3. Okay, so we have a condition like this. Okay, so this is I1. So this here, which concept will apply here, students? Which concept we can apply here to find out I2 and I3 if I already know the value of I1?
KCL.
Okay, no, direct KCL, no. I'm asking about the concept as per this question.
They R2 and R3 are in parallel, so you can use the voltage divider technique.
Just a moment, just a moment. I am asking between voltage divider and current divider, which rule you can apply here?
Current divider.
Why?
Because the current is getting divided. I1 is getting divided into I2 and I3.
Very good. Okay, so current is getting divided into two parts. So here we'll be using current divider technique. Okay, divider technique to find I2 and I3. Okay, so what is resistance value here, student? This and this. Can you tell me the value?
4 in the first one and 6 in the other one.
This one?
Yeah, 6 then.
6. Okay. Okay, so as per the current division rule, I2 here should be equal to total current I1 multiplied by resistance of the opposite branch, that is 6 ohms, upon total resistance. Okay, and so this will come out to be I total I is 2 into 6 upon 10. So this is 1.2 amps. Now when you talk about I3, it should be total current multiplied by resistance of opposite branch, that is 4 ohms, upon total resistance, that is 4 plus 6. So this value I1 I know as 2 into 4 upon 10. So 8 by 10. So I3 came out to be 0.8 amps. Okay. Now suppose if this is V2, that is voltage across 4 ohms, and if this is V3, voltage across 6 ohms. Can you tell me what should be relationship between these voltages V2 and V3?
Same, sir.
Why? Why same?
Because it's parallel connection.
Okay, so what do we mean by why voltage will be same in parallel connection? Because one end of, like I'll mark it as one end of both the resistance is connected to a common point, and the other end of both resistance is connected to another common point. Okay, so this is like you can see that this is connected to two common points, the two ends of the resistor. Okay, so the voltage will always be same for these two, because these all points are at same potential and these all points are at same potential. Okay, so V2 and V3 should be equal. Let's put the value and justify this. V2 here is nothing but I2 multiplied by 4. I2 we found out as 1.2 into 4, so it is coming out to be 4.8 volt. Now let's talk about V3. So, okay, I'll remove this. Okay. So when we talk about V3, it is nothing but I3 multiplied by 6 as per Ohm's law. I3 came out to be 0.8 into 6. 6 8 is 48. So this is again 4.8. That means what concept we just talked about, common points and same voltage. We have proved this, that V2 and V3 are equal, that is 4.8 volt. Okay, so how much current value where it is I1, I2 is 1.2, 0.8. Okay, so okay, so these are the values of this current. I1, as it is mentioned, like 2 ohms is following, so 2 ampere is going on, so 2. Okay, here we found out both the values as 4.8 volt. Okay, so now what we have, what is left now, we have to calculate V1 and this Vs. Okay, other things we have calculate. So can you tell me now some trick to solve this? Anyone? Okay, let's simplify this circuit more. Okay, so this circuit, which is combination of 4 and 6 ohms. Okay, sorry. So two, two. Okay. So this is nothing but a parallel combination. So what is resultant or equivalent between these two? So this equivalent resistance is nothing but R1 R2 upon R1 plus R2. So this is 2.4. Okay, now this will look like this. That is 2 ohms and 2.4 ohms connected to a 2 ampere. Okay, so now you can see here these two are in series. So here this R equivalent will be individual resistances, that is R1 plus R2, that is 2 plus 2.4, that is 4.4 ohms. So you have a situation now which says you have a current source connected to a resistance of R equals 4.4 ohms, and this is 2 amps. So what can we talk, what can we say about the voltage associated with this? Any idea, students? Or you can think of anything here.
You can just use Ohm's law directly.
Okay, so what voltage you will get? You mean to say this?
8.8.
Okay, so this is something that will say that if a current source is always represented by a current source having a resistance in parallel. So if we want to replace this with a voltage source, we have to apply